should we wait or gonna start?
We'll just wait.
Yeah, just wait for a second. Yeah.
But maybe I must admit that I'm very fortunate in that I often get the chance to go to La Jolla in California. It's one of my favorite places. And I always think it must be wonderful to work at the Scripps Institute. So just while you're waiting for people to come in, do you want to say something about the Scripps Institute?
Yeah, absolutely. Scripps, not this time, but usually I will include one slide to show where the Scripps located. Scripps are really located on the Southern California coastline. I don't know how many of you visited Scripps before. It's in the coastline next to the North Torrey Pine Golf Course. It's a very, very beautiful place to work. Scripps is actually is a very I think it's at one point is the world's largest private research institute. Probably not anymore, but nevertheless we have about 200 faculties in Scripps Research Institute. And we cover a lot of in the drug discovery, translational, genomic data research. There's Eric Topol leads the Translational Institute and to participate in a lot of large genomic projects like All of Us and digital medicine, precision medicine projects. So I'm from I basically lead a bioinformatics group there. In the integrative structure and computational biology, doing a lot of the data infrastructure type of work. And if you heard me from a previous talk from the BD2K talk, you probably know I'm mostly one of the main focus for me is the focus on the building the biomedical APIs and try to build the, not just we build the API for the end user, and also we try to build the tools to help other people to build their own API, and also how to get the API linked together. So, and I covered a little bit of myself.
Yeah.
Yeah.
So we'll just wait 1 minute before we actually formally start the presentation, just to give people time to come in, because I hear that people are finishing in the other rooms. So
yeah.
We like to keep on track, because I know that people do want to cut between different groups. Yeah, so I'm not sure it's the... When he's talking after Okay, so I think we can formally begin now. So very pleased to welcome our next speaker, Chunlei. And you're going to talk about some of the activities that are happening at the Scripps.
Yes.
Okay, thanks.
Thank you, organizer. Yeah. Thank you, everyone, joining this session. And for the people who just joined the session, I'm Chunlei Wu from Scripps Research at La Jolla, La Jolla, California. Today I'm going to talk. Oh, is this not working? Oh. Here you go. Better? Yeah.
Could you turn up the microphone? The main mic.
Hello, hello. Testing?
Yes.
Good? Yeah. All right, great. So, maybe too much? Yeah. Okay. Yeah, today I'm going to talk about this BioThings API project. And we really focus on this biomedical API because we think the biomedical field really need a lot of API. We don't really have a lot of good, high quality API, and we want to develop tools, and we provide the API, try to help the community to get access to the more high quality and more sustainable biomedical API to support the more reproducible biomedical research. That's basically our focus. So today's talk really focus on one component of our so-called biomedical API development system, and really try to do is try to help the people to develop their own APIs. That's what we do. Okay. So I think for this crowd, I don't really need to talk too much about the API, but API is really application programming interface, and really, to me, I feel like a data API is just a very good way to abstract the data access layer, right? So in terms of data access layer, typically when we develop an application or the workflow, you're probably going to divide it into this so-called like a model view controller type of a design pattern, right? So you have the data layer, talk about you store data somewhere and you keep it up to date, and you serve some logic layer on top of that, and then represent the result in that presentation layer. That's like a typical process. Now, when you into this software development, you will soon realize a lot of repetitive data wrangling in this data layer process, right? For example, if you have you deal with the gene, you may want to download the gene from NCBI or Ensemble, and then you keep it in your local database, and later you want to develop an infrastructure to keep things up to date, right? It's a lot of work. And then other people develop the same thing. Or even in your same lab, another people to come to develop another application, they might need to repeat itself, right? To develop another parser or fix the parser over the time. That's a lot of repetitive data wrangling here. So what we want is we want to abstract that out and creating another, like a common data layer other people can use, so that at least for this part of the work, you don't have to repeat it yourself. And so that you can either build your application, maybe it's good enough, maybe you don't need a data layer at all, or you can combine the common data layer and combine with your much thinner data layer to develop your own application. That's the idea. Okay, so this slide is another way to summarize why we need more APIs. It's really about the modularity, reusable, so that you don't like repeat yourself in terms of developing all this data wrangling process in your application development flow. Okay, so this is what we did at beginning of our project. We developed this so-called MyGene.info API. It has been out there for quite a few years, and you can see like this is a very popular API, really focused on the gene annotations, everything about gene. So for example, if you want to know the gene, give us the gene ID, Ensemble ID, NCBI gene ID, even a retired gene ID, you can get back the information about that particular gene, whether this is from the UniPro, from the or some specific pathway database. We all aggregate together so that you can get like a one-stop place to access this data. So you can see this right now is very popular, used in the application. This is just 10 million, is just like in the last 30 days. Average, we got about 10 million requests right now from 14K unique IPs, almost like every month. People use it in workflows, in live applications, or simply just dump the data, cache it locally so that they don't have to do it. So that's one thing we like people to use our live API. So this is how the MyGene.info works. This object will look to return something like this. Have a gene ID, return everything about the gene. It's pre-structured, that's it. And you can easily to use. And this is probably the real world that object looks like, but you can specify what particular field, subfield you're gonna need, right? So you don't have to get the whole object at one time. So this is all just the list of the sample example of the data source we pre-aggregated together, and also this data is kept like every weekly update. So this is a very tight update. I don't think it's very very common in the biomedical field that we actually keep this very tight update frequency. Okay, so then once we have this data pre-structured, you can access the data through a very simple interface. And for example, I mentioned if it's a gene, you just the gene ID. That's it. And you can specify the fields so that you can pick whatever you like, the subset of the gene object. You can also query whatever field. You can query almost like every field in the data structure. It's queryable. Like as example, you query for some particular pathway, you can get back all the genes associated to that pathway, right? So, and also we support the batch query, do the user post. Okay, so with the relative success of the MyGene.info, we start to build other biomedical APIs to extend our family of BioThings API. So with the BD2K funding, we built this so-called MyVariant.info, which is focused on the gene human genomic variants, right? All the annotated API, all the annotated source from the focus on the variant, we aggregate together. You can access it through like a kind of a HGVS names. So, and you can also do the query. And I don't have time to talk in more detail, but you can get the information about this from the myvariant.info. And more recently, we developed this mychem.info, really focused on chemical and the drugs. So it's the same idea. We do the aggregation for you and get all the information from the different resources, pre-structured in a very simple, straightforward JSON object, and give you the very high performance, user-friendly access through this API. And we also have the small brother in this family called my disease info. Is focused on the disease, but this is a really we just get started, but you can still use it right now. And also this is an API for the taxonomy. It's small, but very specific and very useful. Okay, so really for all those BioThings API we developed so far, we think that our user really like it, and mostly because we built this with a lot of usability in mind. Let's try to make this, it's like built for the developers so that they can actually rely on our API to build their live applications. It's very simple to use, comprehensive, and cover a lot of annotations. It's very developer friendly. If you are a developer, you're probably familiar with all those terms, CORS, gzip, and HTTPS, message pack, all this. You're probably going to find this is very useful. I won't talk too much about that. And also, we provided the Python, our JavaScript client to access those BioThings APIs. And another point I want to emphasize is really the sustainability, right? So if you develop an API, you meant to be reused in a lot of application or workflows. You really want people to rely on that. You want to make sure that your API is sustainable. A, of course, I need to work hard to get the funding to support that. B is that this data source we have, we want to keep it very up to date. We build the infrastructure to update the resources very frequently so that you can rely on us. You don't need to worry about the outdated data. It's always up to date. And also the high performance. And then when we get the more and more user, we want to make sure the performance doesn't decay, and we make sure that we can scale by adding the more apps on nodes, right? So, and also we want to make it a very high availability so that you can really rely on that. So this is all that we think is the best practice we can put into a biomedical specific API. And all of this, and to summarize, is really like we want to provide an enterprise grade API for biomedical research field. So now, really, besides all this API we developed, we really all want to help other people to build the same high quality, high performance APIs. That's why we put all those best practices I just mentioned into this Python package called BioThings SDK, so that that can help you to turn a biomedical data resources into a high-performance API like the ones we built. So that actually abstracted this whole piece. You have the different source here, and then you can write a specific parser and turn the data source into whatever structure your a JSON object. Then here, this SDK will help you to monitor the data source, harvest, and merge together, index it, and produce the user-friendly API endpoint for the end user. That's how this package is gonna do. You can get it from the Python PyPy with the pip. And today I'm gonna talk a little bit more about this so-called BioThings Studio. This is a web application sits on top of the BioThings SDK, and it's a web-based development environment meant to make this API development process even more easier for the developer. And this is a work I highlighted is mostly led by the Sebastian, senior developer from my team. So as you can see here, I mentioned about my GeneInfo, right? So this is basically the BioThings Studio interface for my GeneInfo API in production. You can see all these resources. Each box is one resources. We monitor each resources. If you see this one, that means this is an ensemble. That means there's a new source downloaded. It's gonna in the process of upload it and updated our API. If you notice, this has a red bell. That means it just call for our developer team's attention. Maybe something wrong. Maybe the source changed the format. We just need to fix, or maybe downloading failed, something like that. So we developed this this is like a platform to help us to keep everything together, everything up to date, so that you can use the data. B is like this whole thing can be used by you as well to manage your data source and build the API. So here's one example. Suppose we use, we want to turn a new data source called FEWARS. This is a data source developed at Vanderbilt, and it's just like a GWAS. This is a phenotypic wide association study, right? So this is at the FEWARScatalog.org. So they provided the data available, and so we want to turn that data as an API so that other people can use, or just use in your applications. So here's what you can do with the BioThings SDK and the BioThings Studio. So you write the parser. You still need to write the parser. Nobody's going to help you that. So you understand data. You still need to write a parser. You define your own data object you want to put into the put as the output of your data parser. And then you have this so-called manifest file to describe a little bit about this data source. We want you to specify a license. This will come from the data, this data source. And here you have the data URL. This is just how we can download the data for you. With that URL, we can track whether this data source is updated or not. It can be done all automatically. We actually just check the HTTP header for that. Okay, so then next you can register this as a new data source, just putting that little your GitHub pass to your GitHub repo. Then the data source is updated. Now you can see here. Oh, by the way, I want to mention the BioThings Studio actually just we provide it as a ready-to-use Docker image, so you can just launch your local environment by just running it in your Docker container. It's very easy to get it started. We install everything for you. So now in that interface, you can have this data source as is now included as a data source in the BioThings Studio. This, you can dump the data. That means you can download. And here, you can upload. And then this one is you can inspect the data to check the data output. So here, okay, we can trigger the download and trigger the upload. That means run your data parser, put the data into the backend MongoDB collection. And then another one I want to highlight, you can actually inspect the data come out of your data parser. Here, A is you can check the data consistency, right? Whether this is one particular field, maybe have a mix of a string or integer, that will tell you that. And A, this will try to automatically creating an Elasticsearch mapping file for you. And you can also still customize it if you need, but this will save you some effort by automating like inspect the whole data for you. So now next step is really you can now since your data is there, data is good. Now you can actually make an API. Firstly, you want to create a new data build for the one data source. Here we only have the one data source. This data build basically just means copy that data source. But if you have a multiple data source, the data build basically means you need to you can basically merging all this data source into single data build. That means, for example, if you have the gene, maybe all your data source are going to have the same gene ID, then all data source going to merge it by the gene ID. That means the data build. Now that data build is done, and next step is really creating the new release. That creating the new release involves indexing your merged data collection and make it ready to serve by the API. And then you can say, create the new API, pick which one data source you're going to use, and that's it. And then last step, and great, set up the port, and then your API is running on your Docker, on your laptop, so you have the API, at least for your dev right now. So, and now all this has a similar BioThings API features, also accessible from the Python, R, JavaScript client. It called a BioThings client. So, great. So we can actually even host your API. If your source is very relatively small, we can just host it for you, just to talk to us. If you are a bigger project, a bigger organization, we can also help you, and we probably can develop some collaboration with you to help you to host that. And all the hosted API right now is at pending.biothings.io. If everything is we think is a good source, can be used by a bigger community, we can merge into our other more mature, like my gene, my variant, my CAM, my disease APIs. So you can check out that. And this is pretty much the last slides. I want to summarize what the BioThings API as a whole API development ecosystem, right? So we mentioned that we have this accessible part that really is, we provide API. So maybe you don't have to build your own API. That's part if we provide that. And another is like today's talk really focus on this part, how to make the data reusable and by building your own APIs. And we provide a tool, BioThings SDK and the BioThings Studio to help you to do that. And even this corner we didn't touch in this talk is really about the after you build an API, how do you make your API more discoverable? We have the Smart API project really as an API registry, help you to document that and annotate your API so that other people can find your API. And also BioThings Explorer really talk about the API interoperability by chaining those API after you do the semantic annotation of the API input-output. So I don't have too much time to talk about that, but if you have an API ready, we can help you to make your API more findable and interpretable. And you can reach us at all these channels for the BioThings API page. And this is all the teams that work on this project. Thank you.
Thank you, Chunlei.
I have some flyers here if you want to take one.
And as if by magic, I think, can you hear me? Is that coming through? Yes, okay. Right, everyone please come in for the next talk presentation. But in the meantime, just ask if there's anybody got a quick question for Chunlei, wants to make a comment, got a thought, observation? Yeah, okay.
Very nice. So the BioThings SDK, that is like a framework for creating APIs. When I create my API, how much can I extend it to create like new endpoints? I mean, I guess it comes with a fixed number of endpoints, the API. How can I extend it? And second, if it creates like an automatic reference, like an open API documentation or a Swagger.
Oh yeah, right now it doesn't auto-generate OpenAPI, but Smart API really is about once you have the OpenAPI documentation, it will register and it renders the API page for you. But if you create a BioThings API, all the BioThings API query endpoint is very similar. You might just copy the one we have, like my GeneInfo one, modify for your own purpose. It's very easy, yeah.
Okay, Chunlei, thank you very much. It's very kind.